स्टार्ट करना है और क्या शुरू करो. Yeah, good morning all of you. See, we are going for only examination point of view. In this, the most important LAQ is law of conservation of energy in case of freely falling body. We have to prove law of conservation of energy in case of freely falling body case. Okay. First of all, what is law of conservation of energy? Law of conservation. Law of conservation of energy. Okay. Law of conservation of energy means we never create, we are not creating the energy and we are not destroying the energy, but energy is transformed into one form to another form. That is law of conservation of energy. That means, suppose when we switch on the fan is rotating. That means electrical energy is converted into mechanical energy. When we switch on the fan, that means electrical energy we are using converted into mechanical energy. Mechanical energy means fan. Okay. So like that, energy is transforming from one form to another form. We are not creating any energy, just only changing the form. Okay. That is law of conservation of energy. Okay. Now, this we have to prove in case of freely falling body. Before going to that, we come to know what is kinetic energy and what is potential energy. First of all, potential energy. Potential energy. Potential energy means, for example, at the ground, on the ground, certain body is there. If you want to lift this body from this point to certain height, okay, up to this height, you have to lift it. How much height you are lifted? That is H. So, potential energy, PE formula, generally the work we are doing. So, work formula, force into displacement. Here, force is mg, gravitational force. And S is, here S means height, H. So, the potential energy formula is mgh. Okay. We are lifting the body from certain ground to certain height. We did some work. That work is its potential energy. Okay. Next, another one is kinetic energy. Kinetic energy. So kinetic energy means when a body is in a motion, when any body is in a motion, it possesses some energy. That is called kinetic energy. Formula half mv square. Half mv square. So Ke is equal to half mv square. Okay. Here what we are discussing here, once we will recall it. Law of conservation of energy. Law of conservation of energy means we are not creating any new energy and we are not destroying any new energy. Just energy is transformed from one form to another form. Okay, that is law of conservation of energy. What is the example? One example I am saying. That example is when we switch on the light or a fan, the fan is rotating. When we switch on the fan, that is electrical energy is using. That electrical energy converted into mechanical energy. The fan is rotating is a mechanical energy. Okay. So that is law of conservation energy. Here, what are the kinds of energies are there? There are two kinds of energies are there. One is potential energy, another is kinetic energy. When the potential energy is applicable, if you want to lift a body which is at a ground, you want to lift that body from ground to certain height, you are doing some work. That work is equal to Fs, force into displacement. That force is mg. Here gravitational force is using, and S is the height. How much height we are displaced. The total potential energy formula mgh. Next, kinetic energy. Kinetic energy means when a body is in motion, suppose one bus is moving with some velocity, Okay, it has some energy. That energy is kinetic energy. That kinetic energy formula half mv square. So these are the two kinds of energies are there. Now we have to prove law of conservation of energy in case of that freely falling body case. Okay. So now we go for that. Freely falling body case. Law of conservation energy in case of freely falling body case. Okay. Now see this. Suppose a body is at a height of A, at A, okay, at B, and at C. This is the third point. Now, you see, suppose certain height, how much height it is? It is a height of H. Height is the H. From this height, you are dropping one body that is falling from this height, from the top to bottom. At a three different points are there, A, B, C. At point A, how much potential energy is there? How much kinetic energy is there? From that, we can find the total energy. Potential energy plus kinetic energy, that is the total energy. Everywhere at point A, at point B, at point C, all the points we have to find out. Okay. Now we'll go for at a point A. At a point A. At a point A, we have to find out. Okay. Now, see here at a point A, first we will go for kinetic energy. Kinetic energy means initial velocity. U is 0. That means we are lifted the body like this. Okay. Now suppose it is a point A. Here any velocity is there? No. Velocity is 0. If velocity is 0, kinetic energy is also 0 because kinetic energy formula half m u square or here velocity. Okay. So that is 0. It is 0. So kinetic energy is 0. At a point A, kinetic energy is 0. Now, potential energy. Okay. What is the height here? Height is h only. So potential energy formula mgh. So it is mgh only because height is, suppose I will make it capital H, that's better. No confusion at all. It is a capital H. Okay. So then here it is a capital H. Height is capital H. Then mg capital H is your potential energy. Then we can find total energy. Total energy is kinetic energy plus potential energy. So kinetic energy 0 plus potential energy is mgh. The total energy is mgh. It is the total energy at a point A. Okay. Once everyone go through it, afterwards, once you note down this, and after that I will go for this. Once again, I'm recalling this. Say at a point A, that means here. What is the kinetic energy? What is the potential energy? I want to explain. At a point A, suppose the body is you are holding like this. At a point A means, okay. When you hold like this, velocity 0. So kinetic energy formula half mv square. So velocity 0, so total will be 0. Next, kinetic energy 0. How much height it is? Capital H height. Now we have to calculate potential energy. So potential energy general formula mgh. Here height you have to take capital H. So it will be potential energy is mgh. The total energy is Ke plus Pe. That is mgh only. So total energy is mgh. Now we go for at a point B. at a point B. In this, same, at a point B means here. The body is traveled from A to B of a displacement x. Now the body is at B, and the body traveled from A to B with a displacement of x. So then from this we have to find out potential energy and kinetic energy. Okay. First I will go for potential energy. Potential energy formula mgh. Okay. mgh means, now suppose the body at point B. Okay. So how much height it is? This is the height. Total height is capital H. From here to here is x. So this is h minus x. Okay. At a point B, the body is a height of h minus x. So here height is h is equal to h minus x. Then potential energy is mg h minus x. It is a potential energy. I repeat. Now I want to find out total energy at a point B. Okay. So at a point B, kinetic energy we have to find, potential energy we have to find. Now the body traveled from A to B, it means how much displacement? X displacement. Now the body is at a B, so then how much height it is from the ground? If it is a body at B, that means this displacement you have to take it, this distance. That is h minus x. How it came? Total height is capital H, and this displacement is x. So this difference is h minus x. Is it okay now? So now potential energy is mgh. So this is h minus x. It is a potential energy. Then we go for kinetic energy. Kinetic energy means the body traveled from A to B. If the body traveled from A to B, it has some velocity. Okay, that velocity we have to find out. The body traveled from A to B with a displacement x. Okay, so we have to find velocity by using the equation v square minus u square is equal to 2as. This equation we have to apply. For this, initial velocity u value is 0. Okay, we have to find out a value is g value, because the body is falling down. When the body is falling down, okay, we have to apply acceleration is equal to acceleration due to gravity. Then s value is x, because the body is displaced, x displacement. You apply all these values in here. That is v square minus 0 is equal to 2g x, sorry, displacement is yes. So x we have to apply it here. Okay, so v square is equal to 2gx. Then kinetic energy half mv square, that is half m. V square is 2gx, that is mgx. It is kinetic energy. I repeat this thing once again. See, the body is displaced from A to B. How much displacement? X displacement. Okay, so displacement is x. When the body is falling down, that acceleration is acceleration to gravity, that is g. Initial velocity is 0. I want to find out velocity, final velocity. Okay, using this equation, v square minus u square equal to 2as. Final velocity v square, u square is u is 0, 2, a means g, s means x. So v square is 2gx. Apply the kinetic energy equation, k is equal to half mv square. So half m, this v square is this. V square value is 2gx. Then 2 to cancel. The remaining is mgx. That is kinetic energy. Now you have to apply total energy at a point B. So total energy is Ke plus Pe. that is equal to Ke means mgx, Pe means mgh minus x. Better I want to split this, that is mgh minus mgx. So I will write that mgh minus mgh minus mgx. So it is, these two will be cancelled, remains mgh. So total energy at a point B is mgh. This is equation 2. Here once I repeat it, total energy I found. Total energy means potential energy plus kinetic energy. You see kinetic energy expression is this. Potential energy expression is this. Then these two will be cancelled. The remaining is mgh. So that is the total energy. Okay. So total energy is this. Total energy at a point B also we got same equation mgh. Total energy at a point A is also same mgh. Then we go for total energy at a point C. At a point C. Once again, I will draw the diagram here. Total height is capital H. This is a x and this is h minus x. Now we have to discuss total energy at a point C here. This point we have to find total energy, means kinetic energy and potential energy. So first, potential energy. Height at a point C, that means here. Height is 0. So potential energy is mgh. That is mg, h stand for 0. The total is 0. At a point C, potential energy is 0. I repeat, at a point C here, we have to find potential energy and kinetic energy. First of all, potential energy. Formula mgh. Here, mgh. Here it is. At a point C, the height is 0. So h0. The total potential energy is 0. Okay. Now we have to find kinetic energy. Kinetic energy half mv square. So you have to find velocity. How the velocity will come? The body traveled from A to C. The displacement is capital H. So how much velocity it acquire? By using the formula v square minus u square is equal to 2as. Okay. So first we start with velocity. So v square minus u square is equal to 2as. In this velocity, final velocity you have to find u 0, a, g, s. S means here h, because at a point C means you have to take total displacement, that is height, total h. Then you apply here all. V square minus 0 is equal to 2 g, s means h. So v square is equal to 2gh. So then here I am writing kinetic energy is equal to half mv square, half m. V square stand for 2gh. Then it is mgh. It is the kinetic energy. I repeat, velocity we got 2gh. So kinetic energy we should come to know it. That is half mv square. half mv square stands for 2gh. Okay, 2 to cancel. Then what it remains? mgh. So then total energy is equal to Ke plus Pe. Ke is mgh plus Pe. Pe is 0. That is mgh. Okay, this is the third equation. I repeat, total energy, kinetic energy plus potential energy. Kinetic energy is mgh. Potential energy is here we got potential energy 0. So total will be mgh only. Now you compare all the three equations, equation 1, 3, 1, 2, 3. All three equations you compare it, you will get same equation mgh. Okay. So from equation 1, from equation 1, 2, and 3, total energy is mgh. So what is the conclusion here? Total energy always constant, either A, either B or C, wherever it is. Total energy always same. Okay, that is the conclusion from this discussion. In examination point of view, it is the most important long answer. Okay, law of conservation of energy in case of freely falling body. Once you go through it, so next we go for another important long answer. One long answer is over. Next, another long answer is collision. Okay, collision. What is collision? Different types of collision and elastic collision in one dimension. So this is the one important long answer. It is there. In this, first of all, you see what is collision I'm discussing here. Suppose you throw one object here of mass m1, initial velocity u1. Suppose you throw one object here, afterwards you throw another object of mass m2, initial velocity u2. Both will be collided here. Okay. So m2 later on, first one is m1, initial velocity. After impact, the two bodies will travel with different velocities. Its velocity is v2, its velocity is v1. You see this? In practically day-to-day observation also, you can imagine it. Okay. Sir, చూడండి అవుతుందా? ఇప్పుడే చేంజ్ అయ్యింది అది. జస్ట్ 1 or 2 minutes. Okay, na? Now see this collision. What is this? There are two objects. First body of mass m1, initial velocity u1, you thrown, and you take another body of mass m2, initial velocity u2, you thrown. Both will be impacted here. After impact, both will travel with a different velocity v1, v2. Mass will be same. Mass does not change. Okay, that is called collision. Collision means a deep impact between two bodies, due to which their momentum will be changes. Momentum will be changes. Okay, that is a collision. Okay, in this types of collision, there are two kinds. One is elastic collision. Types of collision. Types of collision. One is elastic collision. Types of collision. Okay, in this types of collision, one is elastic collision. Another is inelastic collision. Inelastic collision. Okay, elastic collision. Elastic collision means during this collision, both linear momentum and kinetic energy both are conserved. Linear momentum and kinetic energy both are conserved. That is elastic collision. Both are conserved means before collision, after collision, linear momentum same. Before collision, whatever the linear momentum is there, after collision also same linear momentum will be there. That is elastic collision. Okay. Inelastic collision means only linear momentum is conserved, kinetic energy is not conserved. I repeat, in these types of collision, elastic and inelastic, elastic collision means linear momentum and kinetic energy is conserved. That's a constant. Okay, both are constant. But in case of inelastic collision, only linear momentum only constant. Linear momentum constant only. Linear momentum constant. only. That means kinetic energy is not constant in case of inelastic collision. Okay. So this we will go for in detail. The next topic is elastic collision in one dimension. Elastic collision in one dimension. Elastic collision in one dimension means that is same earlier what we discussed here. There are two bodies are there. Both will be impacted here. After impact, both will travel with different velocities. For example, it is m1, m2, u1, u2. After impact, its velocity is v1, v2. Okay. Before collision it is, after collision it is. Okay. It is before collision. Before collision, and it is after collision. As per law of conservation of linear momentum, we'll discuss now. From law of conservation of linear momentum, law of conservation of linear momentum. Otherwise, I will write up to this equation will come. Yeah, okay. What is the law of conservation linear momentum? Before collision, what is the linear momentum? First body linear momentum, m1 u1. See, I think you know linear momentum formula mv. Linear momentum formula mass into velocity is linear momentum. Okay. So first body linear momentum is m1 u1 plus what is the second body linear momentum? m2 u2. Okay. It is total linear momentum before collision. That is equal to after collision. What is the first body linear momentum? m1 v1 plus m2 v2. Okay. So it is before collision linear momentum. It is after collision linear momentum. Now you solve it and you will get one equation here. Initial quantities you write in one side, final quantities write in another side. Like m1 u1, like a minus m1 v1 is equal to m2 v2 minus m2 u2. Okay, when it goes there, so m1 is common. u1 minus v1 is equal to m2 common. That is v2 minus u2. Okay, so then it is the equation 1. Next, we go for law of conservation of kinetic energy. Same kind of another equation, we'll get it. From law of conservation of kinetic energy. It means before collision, what is the total kinetic energy is equal to after collision total kinetic energy. That is, what is the first body kinetic energy? Half m v1 square, half m1 u1 square plus second body kinetic energy is half m2 u2 square is equal to first body after collision, first body kinetic energy half m1 v1 square, second body half m2 v2 square. Once you go through that equation, sorry, stop cheyalna, nayarena. Okay, now see this law of conservation of kinetic energy. Before collision, total kinetic energy is equal to total kinetic energy after collision. That is, first body kinetic energy half m1 u1 square. Second body kinetic energy half m2 u2 square. After collision, first body kinetic energy half m1 v1 square, and second body kinetic energy after collision half m2 v2 square. Now you make it everywhere half is common, so we can eliminate it. So what remains? m1 u1 square, u1 square. You send this here half m1 v1 square minus m1 v1 square. Okay. So then here same m2 v2 square, this minus m2 u2 square. You see the from first step to second step, half is not there because in these two terms, if take half common, and here also half you take common and cancel it. So afterwards, I took initial and final values of first one, that is this one and this one. I've written both are in one side, and this I sent to there. So that is m2 v2 square, and when it comes here, m2 u2 square. Now m1 is common. m1 is common. u1 square minus v1 square is equal to, then m2 common, v2 square minus u2 square. It is equation 2. Now you take division of equation 2 by 1. Equation 2 by 1. That is m1 u1 square minus v1 square by m1. Here it is u1 minus v1 is equal to m2 v2 square minus u2 square and v2 minus u2. m2 v2 minus u2. Again m1 m1 m2 m2 cancel. Then this you can split in terms of a square minus b square. A square minus b square. It is a minus b. So what it remains? A plus b remains. I repeat, it is like a square minus b square formula. So that is a minus b into a plus b. So a minus b cancel. So what remains? A plus b. So when you apply that mathematical formula, you will get u1 plus v1 is equal to, here also v2 plus u2. Okay, it is a third equation. Or otherwise you can make into another form, u1 minus ut is equal to V2 minus V1. Okay, maybe we can write like that also. I'm clearing that. When you get this, that is U1 plus V1 is equal to V2 plus U2. Then U1 minus U2 is equal to V2 minus V1. It is the equation 3. U1 minus UT is equal to V2 minus V1. Let's see this elastic collision in one dimension. Elastic collision in one dimension. Okay. Once briefly, I will explain you what I discussed here. When the body, first body is moving with velocity, initial velocity U1, second body moving with initial velocity U2, both are collided here. After collision, both the bodies will travel with different velocity. First body final velocity V1, second body final velocity V2. Okay. It is before collision, I was written here. This is after collision, I was written here. Now here it is elastic collision. So you have to apply linear momentum and kinetic energy. So first of all, law of conservation of linear momentum, you apply it. That is, first body linear momentum m1 u1, second body m2 u2. First body linear momentum m1 v1, second body m2 v2. Okay. Now you solve it, you will get the equation like this. Next, from apply law of conservation of kinetic energy, first body kinetic energy half m1 u1 square, second body kinetic energy half m2 u2 square. After collision, first body kinetic energy half m1 v1 square, second body kinetic energy half m2 v2 square. Okay, after solving, you will get this equation. That is equation 2. Now, equation 2 by equation 1. 2 by 1. Okay. In 2 by 1, m1, m1, m2, m2 cancel. So what it remains? This one. Here, how I solved this equation means it looking like a square minus b square, a minus b. So a square minus b square formula, a minus b into a plus b. So minus minus cancel. So what remains? A plus b remains. U1 plus V1. And here also V2 plus U2. Then I transform into U1 minus U2 is equal to V2 minus V1. It is equation 3. Okay. Then we go for final velocities. You take the equation of V2, substitute in equation 1. You will get V1. Okay. I will do that. Next, we go for, suppose I need these 3 equations. So I will write somewhere here. I'm writing equation 1 and 3 here. M1 U1 minus V1 is equal to M2 V2 minus U2. Okay, this is equation 1. That equation 3 is U1 minus U2 is equal to V2 minus V1. It is equation 3. Okay. Now, what I have to do? Take from equation 3, you take V2 value, substitute V2 value in equation 1, you will get V1. Okay. Now see this. From equation 3, take V2. What is that V2 value? U1 minus U2. When it goes there, plus V1. So substitute V2 value in equation 1. Substitute substitute V2 in equation 1. V2 value in equation 1. So that is M1 U1 minus V1 is equal to M2 V2 value. That value I'm substituting this value. U1 minus U2 plus V1. And again minus U2 as it is. Once you concentrate here, see what I did. Equation 3. From equation 3, I take V2 value. That V2 value substitute in equation 1, I got this expression. When you solve this, you will get V1 value. Okay. So that is, now I will simplify it. M1 U1 minus V1 is equal to M2. You split it. Otherwise, I will go for multiplication of all the values. That is M1 U1, M1 V1 is equal to M2 U1 minus M2 U2 plus M2 V1 minus M2 U2. I want to find out V1 value. Everywhere, wherever the V1 is there, you take that V1 values. This is the V1 value, and here also V1 value is there. So you send V1 to there, and that expression also come to here. Then you will get V1 value. So that is M1 U1. Here this M2 U1 minus M2 U1. This M1 U1, M2 U1, and M2 U2. When comes here minus M2 U2 value, when comes here plus M2 U2, and here it is plus M2 U2 is equal to, here it is M1 M2 V1, here it is M1 V1. When goes there, M1 V1 plus M2 V1. I repeat what I did here. See this value I kept there. This value here and this value also here. Okay, only V1 values are here. The rest of all these values are sent to here. It is M1 U1. Next M2 U1 comes here, M2 U1 minus here plus na, when it comes here minus. Next here M2 U2, when it comes here minus M2 U2. So here this is minus M2 U2 becomes plus M2 U2. Finally, minus M2 U2 comes here plus M2 U2. Now you solve it, you will get V1 value. That is M1 U1, M2 U1. U1 is common. That is M1 minus M2 U1 plus M2 U2, M2 U2, 2 M2 U2. M1 V1 plus M2 V1. That is M1 plus M2 V1. Now V1 is you send this value M2 plus M1 plus M2 value send to here. That is M1 minus M2 by M1 plus M2, and it is U1 plus 2 M2 U2 by M1 plus M2 U2 is equal to V1. So this is the V1 value. Then we have to find out V2 value. How to find out? Take same. See, once I repeat it, what I did, I took from the equation 3, I took V2 value. Substitute in equation 1. We got V1 value. Same way, you take V1 from this equation 3, you take V1 value. Substitute in equation 1, you will get V2 value. Okay, that is the way we have to go through it. Then next step, we'll go for that. So next class we'll discuss that point. Up to this we got V1. The same way, only take the V2 value from equation 3, substitute in equation 1, you will get V2 value. Okay, this is the we can do in the next class. Have a nice day.